Hi everybody, and welcome to another video brought to you by PLCGurus.NET. So you're following along in our ControlLogix PIDE Essentials video series, and if you haven't watched the previous videos, I do highly recommend that you do that so you know exactly where we're at in this video. There's important information on how to set up the supporting ladder logic routines we're going to need in order to model our process. Instructions on how to download and set up the sim panel that you're going to need in order to simulate this process and all that good stuff. So if you haven't watched the previous videos, please do so before watching this one. Okay, so what we want to do today is go ahead and start setting up or configuring the parameters of our PIDE enhanced instruction. So it's important to know that in function block programming, the execution flow, while important, is always secondary to the data flow. In fact, the execution flow is implied by the data flow, and the actual order of execution of the instructions is only relevant within the data flow path. As long as the instructions are executed from upstream to downstream, the actual execution order of distinct instructions is unimportant. You know, we're going to explain that in a minute. But the first thing I want to do before we get into data flow and execution of instructions, I want to go ahead and set up these parameters. So the first thing we want to do is we want to head on over to this little ellipsis in the right hand corner here of the PIDE instruction, and I'm going to click that. And I want to direct your attention to this parameters tab here, and you'll notice in here all of the different parameters accessible to us in this PIDE instruction. So there is just a huge multitude of parameters that we have access to depending on how we're going to set this up. And like I said, there's about 180 of these things in here, and we're going to be working with a small subset of those. Process control PIDE is a hugely complex area or field of study, and there's a lot of different things that you can do or tasks you can perform using a PIDE instruction. So like I said, we're going to make use of a small subset of those in order to model our simple first order plant steam temperature control type process. Okay, so the first thing I'm going to do is I'm going to want to set the visibility, because we're not going to use most of these on here. And what this will allow you to do, you see this little column here, it will allow you to either select or deselect which inputs and outputs appear on the PIDE instruction. And to expedite that, you take note of this. You can sort these parameters alphabetically, which may be easier. So I think what I'm going to do is I'm going to pause the video for now, and I'm going to go ahead and set up the PIDE instruction the way I want it to be set up. And that's just, of course, by selecting or deselecting a parameter. Okay? And then once I come back, you can take a look and make sure that your PIDE enhanced instruction is set up exactly like mine. Okay, we'll be right back. Okay, so welcome back. So I've gone ahead and deselected and selected parameters I actually want visible on our PIDE instruction. So spend a few minutes and make sure that your PIDE enhanced instruction is set up exactly like mine. So some of the names are kind of close. However, make sure that it matches, because each one, as you can see in the descriptions, have a different function. Okay, so take a few minutes to take a look at that, and then we'll carry on. Okay, so now it's time to start wiring this thing up. So you'll notice on the favorites panel, this is most of the instructions that we're actually going to be making use of here to wire up our PIDE circuit. And what we can do is we can just start to drag and drop these inputs. So you notice here, if you just hover, this is an input reference, this is an output reference. These are different types of connectors, okay? And then your standard add, subtract, multiply, different maths and Boolean type expressions. All right, so the first thing we're going to do is let's go ahead and wire up this set point, or this operator driven set point input to the PIDE instruction. So I'm going to go ahead and just double click the blue bar just like we would any other instruction. And if you've downloaded the ControlLogix sim package, you should have an input or a tag defined in there called setPoint. Okay, so this is a real type, and it's going to be designed and mapped over to our sim panel here as the set point for our process. Okay, and to wire that up, all you do is see how it's illuminating green there. You just want to click and hold, and then go ahead over to the set point operator input and drop it on. And there we have it. We have now an input to our PID instruction that's going to be giving us a set point reference. Okay? So an external set point reference wired into the SP operator input of the PID instruction. Okay, so let's go ahead and just keep on doing that. So I'm going to go ahead and add an output now. I'm going to drag it down, and I'm going to give this one a new tag now, and I'm going to call it steam valve. So this is our actual output of our PID instruction that's wiring in to the steam valve. Wiring in finger quotes behind the mic here. I'm going to make an alias, and we have an analog output card in slot number 4. And I'm just going to click that, and well, let's just choose channel 0. We don't actually have a valve, so it's not that critical, but let's assume that our steam valve is wired into local slot 4, output channel 0. Okay? And this is our, I don't know, let's give it a description. 0 to 100%, which equals 4 to 20 milliamp output. Oops. All right, click create, and there we go. So we have a little description on that. So we have a steam valve that takes in a 4 to 20 milliamp in the form of a 0 to 100% output. Okay, good. So I'm going to go ahead and wire this into the CV output. Remember, this is our controlled variable. CV is our output of our PID instruction. All right, let's give this a description as well, just for completeness. We're going to call this valid range. We'll say 75 to 120 degrees C. All right, let's do that. Sure. So we're going to say we have enough heat capacity with our process here to heat our process liquid between 75 and 120 degrees C. With our valve fully open, we can heat to 120 degrees C, barring any temperature disturbance. And with our valve fully closed, we're going to be sitting around a 75 degrees C mark. Okay, so I'm going to go ahead and add 3 more input reference instructions on the worksheet here, because they all sort of work together, and then we'll explain what they do and what the function is. So I'm just going to go ahead and start wiring these things up one at a time here in the following fashion. And notice how this one was a dash line. So a dash line represents that it is a Boolean value. So the instruction knows what type of value it needs to accept, and a Boolean value will be represented by a dash line. And see how these lines are intersecting? This can get kind of ugly as these circuits get more complex. If you simply move the input reference or the instruction around, it will auto adjust for you. Okay, so let's go ahead and start assigning tags to these things. And so this guy is already one we've created. So I'm going to go ahead and double click it, and we're looking for our process stopped bit. So notice the process stop bit here. I'm just going to move some stuff around. You see what I mean? We're going to have to massage some things as we go here. So the process stop, remember, is alias to our pilot light here. So when the process is stopped, this output is going to go high, and this is going to send a 1 or a high signal into CV initialization request. Okay, and what does CV initialization request mean? All right, well, it's when the CV initialization request is high or true, it's going to take whatever value is in CV init value and short circuit that directly to the output. So it's going to short circuit, it's going to let me move that back. It's going to short circuit the value in a scaled value to CVEU, an engineering unit scaled value. And it's going to short circuit a percentage value to CV 0 to 100%. Okay? And what value we want to put here under a process stop condition, if we go back to our loop control auxiliary, is we want to put whatever value we've stored in safe position. Okay? So we're jumping back and forth now to see how all these things are connected. So there's our process stop light. When that's true, we're going to take whatever value we've configured in safe position, and because this is a steam temperature control process, the safe position for us is going to be to drive that valve fully closed. Okay? I hope that's clear. So let's go back to the loop control, and now I'm going to go ahead, double click that, and find CV safe position, and there it is. So what it's going to do, when process stopped is true, it's going to take whatever value is stored here, which is going to be 0 for our process, and short circuit that directly to the output. It's as simple as that, okay? Meaning it's going to drive that valve fully closed. Okay, perfect. And the next thing I want to do is I want to populate CV operator and put the CV hand tag in that position. So remember, when we're operating in hand mode, whatever value we place in CV hand is going to get short-circuited right to the output. All right? So recall from the previous videos that hand mode implies that we are running in open loop control mode, meaning we're ignoring the feedback loop, which we haven't put in here yet, and we're going to say the operator can take direct control over the position of the valve. So whatever value we store in CV hand is going to get output directly to our valve. Okay, I hope that's clear. So I want to head back up to the instruction palette here, and I'm going to make use of this Boolean not instruction. So I'm going to drag this down, and I'm also going to go ahead and grab an input reference, and maybe we'll just drag this over a little bit. I don't know, we'll massage it after maybe. Okay, so remember in the loop control auxiliary and on our sim panel, we have a mode selection operation here. We can be in hand mode or auto mode, okay? And in auto mode, when we're in auto mode, that is, our input data point 2 is going to be high, okay? So I'm just going to head back to the loop control, double click in the question mark, and the hand auto switch here, okay? So notice when this is true, it's telling us that we are in automatic mode, all right? And what I want to do with the output, so the Boolean not, what it's going to do is basically flip the output. So when it's true, the output is actually going to be false, all right? I hope that's clear. And what I want to do is I'm going to wire this up into the manual, all right? So remember, if the local 2i data point 2 is true, this output is going to be false. But what about the auto request? Well, I'm going to go ahead and grab a line or grab that and bring that down to here. So notice now, when the hand auto switch tag is true, we are in auto mode, okay? Otherwise, we are in manual mode, all right? And so these will be two discrete outputs. Let's just move this around. And, ooh, that's kind of looking kind of funky there. Maybe we'll move this out a little bit. Oh, too far. Again, it takes some massaging. So what we've done here is when the hand auto switch tag is true, we're in auto, and it's true, it's going to be outputting a 0 here. When the hand auto switch tag is false, we're not in auto, and we're going to be outputting a 1 here, so we're in manual. All right, I hope that's clear, and it'll become more clear when we test this thing. Well, you know what? We actually have enough here now to test this PID controller in open loop control mode. All right, so why don't we go ahead, save our project, and download it into the emulator and fire up our sim panel to test some of this open loop control functions. So I'm going to go ahead and download. My path is defined, so I can just click the download and download yes. Change it back to run mode, yes. Okay, so let's go ahead and fire up our sim panel by pushing the play button here. Okay, so right away, notice it's linking up, and our process is stopped, and we're in hand mode right now. So notice the process stop bit is high. Okay, and if we go to our loop control auxiliary, we see that. And so it follows that, based on what we explained, whatever value is in CV safe position now is getting short-circuited directly to our output, which is 0. So our steam valve now is fully closed. Perfect. Okay, so why don't we try something here? Why don't we go ahead and start the process up in manual or hand mode? All right, so notice now we are in hand mode. Notice the selector here is outputting a 1, meaning we're requesting a manual operation of our PID controller. And so now whatever value I place in CV hand should get short-circuited directly to our output. Remember what we said there? Okay, so I'm going to go ahead and click on CV hand. And you know what? I'm going to say I want to open this valve to 50%. So you can see here now that it's actually opened it to 50%. And the CVEU is not set up yet. It's not scaled yet. We'll do that in the next video. But I just wanted to test some of these open loop control functions first. Okay, so that seems to be working just fine. And why don't we go ahead and put a set point value in our set point tag. So I'm going to go ahead and say, I don't know, let's put 97.5 degrees C. And notice now we have a set point value of 97.5 degrees C. So you know what? I'm pretty happy at this point. Everything seems to be functioning. We have open loop control functions working. And I think that's enough for this video. I don't want to make these videos too long. It's a lot to digest. It's a lot to get going and set up. So let's end it here. And in the next video, we're going to go ahead and add in the feedback loop instructions that we need, and then dive into some of the actual PID tuning parameters that we're going to need to set up and scaling parameters. So I hope you found this video informative. Please like and subscribe to our channel. Head on over to https://PLCGurus.NET. Become an active member in our community, and thank you for watching.